Hello everyone, in this video we will solve 2017 question paper for UGC NET Computer Science discipline. And if you want to download the presentation that is used in this video, then you can visit our website www.digimento.com, and over there you can go to the download section. From the download section you can download the presentation PPTs for this video, as well as you can also download the previous year UGC NET question papers. If you want to take the course for UGC NET Computer Science or UGC NET Electronics Science, then you can visit our course section to get the fees details and to take the courses. Or you can also call us on the contact numbers provided above. So without any further delay, let us just start solving the question paper of 2017 UGC NET. I hope that this video will be very helpful for you, and this will help you in your UGC NET exam preparation. For the complete video lectures, you can visit our website, and this video is available for each and every one of you. So let us start.
Question number 21 is, which of the following is true for computation time in insertion, deletion, and finding maximum and minimum in the sorted array? So they are talking about the sorted array. Let's suppose one example, and with the help of example, we are going to perform these different operations. So let's suppose this is an array, and this array is sorted initially, right? So first element, let's store 1. Next element, let's store 2. Then we going to store 4. Then 6. Then 7, and this is 8. Okay, and this is the array A. Now let's do some operation on this array. So operations which are given in our questions are like insertion, and we have to find out the time complexity they are taking by performing these operations. So the first operation is insertion. Let's suppose I want to insert element 3 in this sorted array, right? So where I'm going to insert this element 3, I'm going to store here at this position, right? Because 3 is greater than 2 and 3 is less than 4. Then in that case, what will be the result? If I placed 3 here, then all the elements before this going to shift one position. Let's suppose the size of the array is more like this. So in that case, 3 is here, then 4 is here, then 5 is here, 6 is here, 7 is here, and 8 is here. Okay, so shift operation is going to happen after insertion, right? So in a worst case, it will take order of n time, because we inserted and then all the elements which is present after this. So the entire list going to shift right? So it will take order of n time. In the same case, deletion will going to happen. So if the resultant array is like this, 1, 2, 3, 4, 6, 7, and 8, and some space is there in the array. Now if I want to delete this element, this key in this array, then what going to happen? This block is empty now. So all the list which is present after this will going to left shift, right? So the resultant array looks like 1, 2, 3, because one space is left, is empty here. So the left shift is going to happen. So 6 is here, 7 is here, 8 is here, and some empty blocks are present in the array. Okay. Now, so in the worst case, the deletion type will take order of n, because in this case also the shifting of all the keys are going to be happening. Now next one is maximum. So let's suppose this is the array 1, 2, 3, 4, 5, 6, 7, 8, 9. The size of the array is 9. Now in this array we want to find the maximum element. You know that this is a sorted array, so where the maximum element should be placed? In the last position, right? So you can easily go to the last position and access the element and find the element. So it will take only order of time. In the same way, minimum key present in the array, where it's going to be placed? at the first position, because it's a you can say it's a sorted array, and it's a in the increasing order, right? In an increasing order. So the first minimum element placed at this location, so it will also take the order of 1 time. So correct answer is, for insertion it will take order of n time, for deletion also it will take order of n time, maximum के लिए order of 1 and minimum के लिए भी order of 1. So option 3 is the right one. Now question number 22. The 7 elements A, B, C, D, E, F, G are pushed into a stack in a reverse order. In a reverse order means first we pushed G, start from the G. First we pushed G, then we push F, then we push E, and then we push D, and then we push C, because they said that stack is popped like this. So push B and push A. Now come to the question. The stack is popped 5 times and each element is inserted into a queue, right? So this is my stack. If this is my stack and push operation is like push G, first push G, then push F into the stack, then push E, then we push E into the stack, then we push D, so D is here. Now the fifth one is push C, because we are going to push in a reverse order. The order is initially is A, B, C, D, E, F, G, and they are asking in a reverse order, so we start from G, F, E, D, C, B, A. So next one is C, so we push C into the stack, then we push B, and then we push A. So B is here and A is here. So first task is completed. Okay, so we push all the elements into the stack in a reverse order. Now they are saying that the stack is popped 5 times and each element is inserted into a queue. It means that हमें 5 times pop करना है stack में से 5 elements को. 5 times means 5 elements which is present in the stack. उन्हें हमें pop करना है और insert करना है queue के अंदर. So this is my queue. And you know that stack is follow last in first out, right? And this is your queue. This is the front end and this is the rear end. From the front end we are going to first in first out, right? We insert from here and we delete from here. Okay, now they said the stack is popped 5 times. So 5 times means first we pop A, then we pop, and each element is inserted into a queue. Okay, so we pop A, then we insert it here, then we pop B from the stack and we insert from this side. B is here. Then we pop C from the stack and we insert in the queue C. Then we pop D and we insert back into the queue, so D, and then we pop E and we insert here in the queue. So 5 times, 1, 2, 3, 4, 5. 5 elements we are going to delete it in the stack. Okay, now F and G are going to left in the stack. Now 2 elements are deleted from the queue. You know that from where we are going to delete it? From here, first in first out. So first A will come, came, so A is out and push back into the stack. So we push it into the stack. Now again 2 elements are deleted now, so we delete B also, and B is here and push back into the stack. Now 1 element is popped from the stack. The popped item is what? Now we are going to pop. So at the top of the stack, which element is present? P. So we pop B from the stack. So they are asking the name of the element. So it's B. Okay. So second is the answer. Now which of the following is a heap, valid heap? Right. You can see that the maximum value is present here. You know that there are 2 types of heap. Min heap, in which root not contain the minimum value compared to your children's, and maximum heap means root not contain the maximum value. Now you can see that they are the maximum heap, because the maximum value is present at the root node, right? Now we have to find out which one of the, out of the 4, which one is the max heap, right? Let's analyze one by one. So 16, 14, 10, yes, it is greater than from their child. Yes, it is greater. Now see from here, see this side. So 4 and 7, 14 is greater, root node is greater to their children. Yes, it is. Now here, so 2 and 8 and 4, so root node should be greater than to their children's. So 8 is greater than 4, right? So this is not a heap tree condition, not follow. Maximum heap condition valid in this case. Now let's see this tree. Now 16 is a root node, it should be greater than the value which is present in their child node. So 14 and 10, 16 is greater. Yes, it follow. Now from here, so 14, 8, 1, 4, this is a root node, they are the childs. So 8, 1 and 14, 14 is greater, so it follows. Now I'm at here, so 2 and 4 and 8, yes, root node contain the maximum value, so it also follows. Now 8, 1, 14, it is greater, 1 and 7. Now see, this is a root node, this is a child. Child contains the highest value than the root, so it violates the max heap condition. So this is not a max heap, or you can say heap. So this is 16, 14, 10, right? This will contain the maximum value. 14, 8, 7. So 7 and 8 and 14, 14 is greater. 2 and 4 and 8, 8 is greater, root node contain the maximum value. 1 and 7, yes, this is right, because the root node should contain the maximum value as compared to their child's. Now 10, 9, 3, 10 is greater and it is present at the root node. So this follows all the max heap conditions. So this is a max heap, or you can say this is the heap, valid heap. So this is valid heap, so option B is the right one. So second option is right. Now question number 24. If H is chosen from a universal collection of hash functions and is used to hash n keys into a table of size m, where n is less than or equal to m, the expected number of collision involving a particular key x is less than 1, 1 by n, 1 by m, or n by n. Let's talk about the hashing first, and then we find what are the problems, or why the number of collision are more in case when we are using only one single hash function, right? So let's talk about the first hashing. You know that in the data structure, right? Data structure, we perform some operations like insertion, deletion, and searching. Let's talk about searching. So if we talk about the different data structures like arrays, linked list, binary search tree, right? Like if we talk about the unsorted array, it will take order of n time, and if we talk about the sorted array, it will take order of log n time. In the BST also, the best case is order of log n time. You can see that the average, if we see the average, then the best case searching time is order of log n time only, right? So we improved it in the hashing, and the hashing will take only the order of 1 time during the searching operation, right? First thing. Now hashing functionality is a mapping of the large numbered set of keys to a smaller set, which is available in the, you can say it's a memory, right? Now let's take one example and see where the collision is going to be happen. The keys, like, so this is your memory. Let's suppose the block's name is 1, 2, 3, 4 and 5 and so on. So these are the blocks and some keys are there. Let's suppose the hash function is like this, modulus of 10. So up to 10 is the size of your memory. Now the first keys you are going to place in this is 121. Now 121 modulus 10, we got 1. So we place 121 at the position of 1, right? Now let's suppose the next key is 132 and modulus 2 with 10, and we got 2. So at the position of 2, 132 is going to be placed. Now the next one is 131 mod 10, and this is 1. So it means that 131 position is also here. Now this is a collision. Now it's collision going to be happen. Next is 151, 161, all are placed in this block, and again and again collision is going to be happen. This is because we are using a single hash function. We are going to use a single hash function. So to resolve this collision problem, we some collision resolution techniques we are already studied, like open hashing or a closed hashing. Open hashing, we are studied about chaining, when more than one key wants to placed at the single position, then in that case some chaining is there, right? And open addressing we used like linear probing and quadratic probing, in which we modified the keys. Now there is one more technique where through which we are able to resolve this collision problem, and the solution name is universal hashing. Universal hashing. Okay, so universal hashing states that it's a very effective way to improve the situation of number of collision. So to here we are going to do is just changing the color, and I'm writing here. In the universal hashing, we choose the hash function. We choose the hash function randomly in a way that is independent of the keys that are actually going to be stored. Okay, so it means that, let's suppose this is a box, right, and number of hash functions are present in this. So we choose the hash function randomly, right? We choose the hash function randomly from this universal hash function box, and that hash function should be independently of the keys that are actually going to be stored. Means that I want to store this key, so I'm going to randomly choose the hash function. It can be anything. Randomly choose the hash function, and I'm going to apply here, and after applying this, the result will came, and from at that particular position I'm going to place that particular key. So this is the universal hashing. In that case, the number of expected collision is going to be very, very, very less. So according to the universal hashing algorithm, this is a theorem. It's not algorithm. This is a theorem in which it states that if h is chosen from a universal collection of hash function, अगर हमने यहाँ से कोई hash function को choose किया and it is used to hash n keys into a table of size m, it means the size of the table is m, where number of keys are less than the size of the m. अगर हमारा size, let's suppose the size of the memory table is 10, then the size, or you can say the number of keys which is present, number of keys should be less than 10. It can be 9, 8, 7, 6, 5, 4, 3, 2, 1, right? So the expected number of collision involving a particular key x is less than how much? So in that case, the expected number of collision involving a particular key x is less than 1. So 1 is the correct option. So this is a theorem. This is a universal hashing theorem. Okay, so first in the initial case we are using only one hash functions for all the keys, but the problem is that particular hash functions always for some particular keys like 121, 131, 151, 161, all are placed at block 1, so it causes collision. So to resolve this problem, we are using this universal hashing theorem. It states that independent of the key you are chosen, choose the hash function in this box, universal hashing function box, and result is the expected number of collision for any particular key x is very less. It means that it's less than 1. So 24 questions answer is 1. Now question number 25 is, which of the following statements is false? So the first statement is optimal binary search tree constructions can be performed efficiently using dynamic programming. So this statement is true, because an optimal binary search tree, all the nodes of this binary search tree are arranged on a level wise, so that the tree cost should be minimum. So we are using this binary search tree in all the dynamic programming to find the minimum cost. So yes, this is true. Now the next is BFS cannot be used to find connected component of a graph. So first thing is, just remember this BFS and DFS, binary first tree, and the DFS, depth first tree, are both used to find connected components of a graph. Connected components of a graph. So this statement is false, and depth first can be used to find the connected component of a graph. This is true. So in the BFS, so we can we can randomly select a source vertex and run BFS algorithm. Let's suppose some vertex are there in a graph, and we choose this is a source, right? And we run the BFS algorithm. So BFS algorithm first initialized finite value to all the rest of the vertex, and the source distance is 0 initially. So after that we need to check each vertex whether its distance from the source is finite or not, right? So after applying this, we find out that still the distance from the source to that particular node is infinite or not. If it is infinite, then it means that this node is not connected to this source node. So we can say that it is not a connected graph. So this is how we are going to identify whether this graph is connected or not. Now, given the prefix and postfix walks of a binary tree, the tree cannot be reconstructed uniquely. Actually, this statement is wrong, because to define the tree uniquely, we are using the pre-order, in-order traversing, and this is post-order and in-order, not prefix or postfix walks of a tree. So we are using this traversal in the tree so that your tree is uniquely identified. So C is the wrong option. So the correct one is option 3rd. Now question number 26 is match the following layers and protocols for a user browsing with SSL. Now the first one is application layer. You know that the application layer provides, you can say the application layer produce the data which has to be transferred over the network. So for that we need this kind of protocol, the hypertext transfer protocol, right? So the hypertext transfer protocol is the right option. Now the next one is transport layer. Transport layer is responsible for end-to-end delivery for complete message. Let's suppose this is a network and this is another network, and this is the host which is present in this network, and this is the host which is present in this network, and there is some process is going on in this host. So this end-to-end delivery is the responsibility of transport protocol, and transport protocol services provided by transport protocol like TCP and UDP. So in this case it may be a TCP or UDP. So if we are using the TCP, then it's a connection oriented service. So this is TCP is a three-phase process, in which the first phase is establish the connection. In the next step it data transfer, and after transferring the data it disconnect or terminate the connection. And there is UDP also. So UDP is a connectionless service, and there's only one phase process. So according to the need, according to requirement, we use this transport layer protocol. So TCP is the transport layer protocol. Now the next one is network layer. So network layer is used for the transmission of data from one host to another host which is located in a different network. So host to host delivery. So from this host to host, it provides by the network layer, right? So in order to identify each host in that particular network, we need some addressing, and that addressing we call IP address. So that we uniquely identify this particular host in this network. So many computers are there. So how we are going to find out, yes, to this particular person we have to transfer the data. So with the help of IP address, I'm going to able to identify. So IP is the protocol for network layer. And the next one is data link layer. So responsibility of data layer is for node to node delivery of message. So main function of this layer is to make sure that data transfer is error free from one node to another. So there's some nodes in between. So node to node delivery is the responsibility of data link layer, and in this case it uses the point to point protocol. So this is a full form is point to point protocol. So point to point protocol, its functionality is used to establish a direct connection between the two nodes. So two nodes is here. So it establish a direct connection between two nodes. Okay, so point to point is used over many types of, you can say, the physical network, which is includes several you can say serial cables, phone lines, or in the, you can say, in the ISP, internet service provider, used point to point protocol for customer dial-up access the internet. So in that case we are using the point to point protocol. Okay, so point to point protocol is a data link layer. So on the correct matching is A is 4 and B is first, C is second, and D is third. So option first is the right one. Now the question number 27 is, the maximum size of data that the application layer can pass on to the TCP layer below is, actually all the options are wrong. The reason is, if this is the application layer and if this is a transport layer, and in above different layers are there, like network layer, data link layer, right, like this. So if application layer send some data to the TCP layer, so in that case it can send any size of the data, right? So there is no limit that define the size of the data in this case, because but in this case, in this layer, yes, there is a limit of the data, but from application to transport layer there is no limit. You can, application layer can send any size of the data. There is no limit. There is no limit. This question is already asked in GATE 2008, then NET 2016, December 2016, and then 2017. So this question is quite important, but all the options are not correct, because the correct option is any size. Okay, in GATE 2008, in the official answer key, the answer is this one. Okay, so this is the correct answer.